In this video, we'll talk about trigonometries. A lot of people refer it as a very difficult unit, but what is difficult is not the content itself, it is more of it requires a lot of practice. In the first question, it is about trigonometric identities, or trig identities. And there are some basic ones we can start with. The first one is sine squared x plus cosine squared x equals 1. And the second is sine x over cosine x. It is tangent x. And the third one is the extension of the second one. When cosine x is over sine x, it is the reciprocal of tangent x, and the reciprocal of tangent x has its own identity, and it is cotangent x. The first one is cosecant x. It is 1 over sine x. And the fifth one is the extension of the previous one. Cosecant squared x can be written as 1 over sine squared x, according to the previous identity. And we can further expand 1 as sine squared x plus cosine squared x over sine squared x. Now we can divide individually. Sine squared x over sine squared x, it is 1. But cosine squared x over sine squared x will be cotangent squared x. The sixth one, it is secant x, is 1 over cosine x. But when it is secant squared x, it can be written as 1 over cosine squared x. And the same, we can expand 1 as sine squared x plus cosine squared x over cosine squared x. And this can be written as sine squared x over cosecant squared x, which is tangent squared x, plus cosine squared x over cosine squared x, which is 1. With this identity, we can start working on the question. The question states show that, meaning this is a proof question. So when we encounter proof, we can start with either left hand side or right hand side. We normally start with a more complicated side. In this case, it is a left. Now we encounter two terms. When we want to combine them, we need to make the denominator the same. So we'll multiply each other's denominator. This is the original term. We'll multiply it with the other side's denominator plus the second term multiply with the other term's denominator. Now we'll just go ahead and multiply. The denominator part is more complicated. We'll have to distribute. This is the first term. Now we'll do this one. Now we'll do this one. Then this. Because the denominator will the same, we can directly plus. Now this one. Then this. Then this. Then this. We will now use the identity 1 plus b multiplied with 1 minus b. It is a squared minus b squared. So we have 1 minus cosine theta times 1 plus cosine theta, and the two terms have the same denominator. So it will be 1 minus cosine squared theta. Now we can simplify the equation by canceling terms. We can see a plus cosine theta and a minus cosine theta, and a plus tangent theta and a minus tangent theta. These are the four terms we can cancel. When we collect constants, it will be 1 plus 1, which is 2. And we're left with cosine theta times tangent theta. There are two of them. and this is all over 1 minus cosine theta. Now we're going to use our first identity, but altering it a bit. Right now we have 1 minus cosine squared. We can move the cosine term to the other side, so we are remained with sine squared x equals 1 minus cosine squared x. So our 1 minus cosine squared theta here is sine squared theta. Now our tangent theta can be written as sine theta over cosine theta, according to our second identity. Now our 2 cosine can cancel. We're left with 2 plus 2 sine theta over sine squared theta. And our final step will be factorizing the 2 out. And this is exactly our right hand side. And after we've successfully proved our expression, we can write QED. This question is an extension of a previous one, and we have successfully proved that the expression is 2 times 1 plus sine theta over sine squared theta. Now we need to solve this when it is 3. We'll first have to simplify this. I'll multiply sine squared theta on both sides to eliminate the denominator. I'll now expand the bracket. Right now we can see a squared sign and a linear sign. So we can have a feeling that this is a quadratic equation. And now we can actually let u equals sine theta. So we don't have to write the entire sine theta anymore. And we'll move everything to one side and make the other side 0. To solve this equation, we'll have to use the quadratic formula. So this is our a, b, and c. Our negative b will be minus 2 plus and minus the square root of b squared, which is 4, minus 4 times a negative 3 times c 2 all over 2a, which is negative 6. And by using our calculator, we'll know the answers are negative 0.549 or 1.22. But note that this is the value for sine theta. We need to solve for theta. By using our calculator and perform arcsine, we can know that the value of theta are negative 33.3 and 270. But our first value, it is outside the range stated by the question. But when we plot the graph for sine theta, we can see that our maximum value will be 1 only, and the minimum is negative 1. So our second value here, it is actually outside of a range. So there will be no solution for it. We can only work with the negative 0.549 here. So by performing arcsine on our calculator, we can get that the value for theta is negative 33.3. But it is outside the range stated by the question. So when we further extend the graph for sine theta, negative 33.3 is around here. And by adding one period, which is 360 degree in this case, we can see that there are another two intersections for this line. So our first intersection will be negative 33.3 plus 360, which is 327 degree. But we know that there's another symmetry here. It is symmetry at 270. So it will be the same distance from 270 to 327 to this unknown value. So 327 subtract 270, it will be 57, and 270 minus 57, it is theta, and it is 213 degree. These are our two answers. The third question wants us to find the value of cosecant squared theta, and we're given the tangent theta value. First, we need to know how to express cosecant squared theta in terms of tangent theta. We know that cosecant squared theta, it is 1 over sine squared theta. And we can expand 1 as sine squared theta plus cosine squared theta. And the denominator is still sine squared theta. So when we divide, our first term is sine squared theta over sine squared theta. So it is 1. But cosine squared theta over sine squared theta, it is cotangent squared theta. And to express it as tangent theta, we can write it as 1 plus 1 over tangent squared theta. So our step will be squaring our tangent theta value. Then we'll find the reciprocal and we'll add 1 to it. So first, tangent squared theta, it will be root of 3 minus 1, 2 plus root of 3, and both are squared. And we'll use the identity a plus b squared is a squared plus 2ab plus b squared, and a minus b squared, a squared minus 2ab plus b squared. So that's expanded. And when we combine like terms, it will be this question requires some knowledge about thirds. If you need help, make sure you check out the video in the description. Now we have tangent squared theta. We can find cotangent squared theta, which is the reciprocal. And because the question requires it in the form of a plus b root of 3, we'll have to rationalize. And now we combine like terms. When we further divide to eliminate the denominator, we'll get 13 plus 15 over 2 root of 3. Our final step will be finding cosecant squared theta, which is 1 plus the cotangent squared theta value we have. This is our final answer. In this question, we need to use another trig identity. It is cosecant theta is 1 over sine theta. And because in this question, our cosecant is squared, so we're gonna put square on both identity. So this equation can be rewritten as 3 times 1 over sine squared of 2b minus pi over 3 equals 4. Now we can rearrange this equation to isolate our sine function. Now our function is in the denominator. We can flip it over to get the function itself. Now we can take the square root of both sides, but be careful because we need to make it plus and minus because the result will be the same. And now the input of the function, which is 2v minus pi over 3, equals to the arcsine of our output. And there are two cases here. One is square root of 3 over 2. The other one is negative square root of 3 over 2. We'll go ahead and solve this. And using our calculator, we can get that it is pi over 3. And this is negative pi over 3. But actually, this is not the only solution to this equation, because when we sketch the sine function, it is like this. And pi over 3 is roughly here, but because our function is actually symmetrical, so the other side with the same height will give us the same output. And because this is symmetrical, so the distance from here to the center is the same as the distance from the center to there. So the other value we have is 2 pi over 3. And for the negative pi over 3, we can extend our curve. Negative pi over 3 is roughly here, so we can know that the other value is here. And the same, it is symmetrical. It is negative 2 pi over 3. But for the sake of this question, we want to make it positive, so we can move our values toward here by adding 2 pi because it is the period of sine. It will be 4 pi over 3 and 5 pi over 3. So right now we can go ahead and solve these equations. For the first one, we'll solve for pi over 3. So 2v will be 2 pi over 3, and v is pi over 3. The second one will be this one. So 2 phi will be 3 pi over 3 or pi. So phi is pi over 2. The third one is this one, 4 pi over 3. 2 phi will be 5 pi over 3, and phi will be 5 pi over 6. The last one is 5 pi over 3. 2 phi will be 6 pi over 3, or 2 pi, and phi will be pi. But notice that the question tells us that phi is between 0 and pi, and it is not equals to pi. So we cannot have pi as an answer. It is rejected. So our final answers are these 3 values. The next question is testing our knowledge about a complete trig function, and there's one shown here. It is y equals a times sine bx plus c. The a here is our amplitude. It determines the height of a function. And the b here determines the period. It is how often the function cycles again. And the c here is our vertical transformation. It changes our vertical height. But what's special about b is that it is actually a reciprocal. Meaning that, let's say if b is equals to 2, the period is actually halved. So we can come up with a relation. It is period 1 times our constant b1 equals our second period times our second constant. So jumping into our question, it has told us that the period is 16 pi. This is our given period. We can write it here. And our b is unknown. But the other side, we can use our regular trig function. It has a b value of 1 because there's nothing there, and the regular period is 2 pi. So if we solve for b, 2 pi over 16 pi, it is 1 over 8. So this is our first answer. Now we can plug in our 1 over 8 and the 2 coordinates given here. Our first x will be 4 pi. And the output is 11. Our second x is negative 4 pi over 3. And the output is 5. There are 2 variables here, so it is a simultaneous equation or a system of equations. My approach of solving it will be minusing downward, so we can get rid of the c very easily. So the 2 c's here cancel out. We only have a left. 11 minus 5 is 6. We can take out RA from the two trig ratios. And using our calculator, the output of this two ratio is 3/2. 6 divided by 3/2, A is 4. Now we can plug it back into the easier to solve trig equation. I'll use the upper one. Using our calculator, 4 sine pi/2 is 4. 4 plus c is 11, so c is 7. And here the highlighted values are our answers.